Okay, section 1.5, this is going to be a two-part video, has to do with measurements. Okay, we're going to start out with a unit. A unit is a fixed standard of measurement. Basically, it defines what it is you're measuring without being there. So a gram is a unit of measurement for mass. Milliliters is a unit of measurement for volume. So the unit tells you what you're measuring and is very imperative for when you're doing problems that you know what those units are to identify what that unit is for or what's being stated for. Next is the difference between precision and accuracy. Precision, of course, is the closeness of identical measurements versus accuracy is the closeness of a measurement to its true value or correct answer. So this figure down here shows the first bullseye shows the fact you have both good precision and good accuracy because the dots are close together. And of course, in a bullseye is a good example for this because of the fact that the center is what you're looking for. Okay, this example is both poor precision and poor accuracy because of the fact that the dots are scattered all over the place. So only one of them is close to the center. So this one's actually got good accuracy. But the rest of these are poor accuracy, and because they're far apart, they're poor precision also. Whereas this one has good precision because they're all close together, but has very poor accuracy because it's not in the center of the dot. So you can have measurements that are have very good precision but have very poor accuracy, or you can be very poor accuracy and precision like this. Although if you're making measurements and then you do an average, you can sometimes rectify this type of measurement because it can still become accurate if I average these. Okay. Next thing is significant figures. Significant figures is something that you see very often in a lot of your science classes, but students still don't grasp why it is that it's important. Okay. So the official definitions, it's all the numbers that are certain plus 1. But why it's important is that if you are the person in the lab doing the experiment, but you have to report to someone else, the significant figures lets the person reading that report or hearing that report know how well you were able to make a measurement. So I have here 3 different graduated cylinders. Okay, the green graduated cylinder over here on the left. Okay, this is a liquid. Okay, and you always measure the volume at the bottom of the meniscus. I can't draw that very straight, but there it is. Okay, so if I were to write this measurement down with significant figures, okay, I know it's between 1 and 2, so I know for certain that it's 1. Okay, however, the uncertain part is what I have to guess at. Okay, so I would say this is about halfway, so we're going to say 1.7. Okay. And you don't know. And then, of course, the unit would be milliliters. All right, the yellow graduated cylinder, now I have divisions, and each one of these divisions is point, so this would be 1, 0, 1.1, 1.2, 1.3, 1.4. Okay, again, my line is right about here. Okay, and so I know with certainty that I have 1.1, 2, 3, 4, 5, 6. I know for certainty I have at least 1.6. Okay. So that's my certain number, but I also have to guess, okay? And if I look at, again, where these two are, it's over halfway. So I'd say it's fairly close to the top there, so I'm going to say 8, okay? So you can see the fact that this one has 3 significant figures because my device to measurement is much better than one that doesn't have the graduations here. I had to guess more. And the last one, the blue one, is actually even the best one, okay? So this one, the difference is that this top number has changed. On the previous 2 examples, they were 2, okay? But now I've changed it so that this is a different one and it's only 1.1. So that means that each one of these dots here, or dashes I should say, is a 0.01. So this is 1.00, this is 1.01, 02, 03, 04, 05, 06. So again, I know I have 1.06, and my dots are not very dark. Okay, and then again I have to guess, so we're going to say it's 0.068 because I use the same figure for all 3 of these. Okay, and the unit again is milliliters. Okay, but this shows the fact that because I have 4 significant figures there, that this is a much more, this device has much greater measuring power for small numbers. Okay, and that's what significant figures shows you. All right. So, if you already have the numbers, how do you determine what's significant and what is not significant? Okay, basically the first rule is that all non-zero digits are significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, are significant. This figure here shows you the difference between significant and non-significant. So all the zeros to the left of the first non-zero digit are non-significant. Okay, so this is the first non-zero digit here. So anything to the left there is not significant. Okay? Oops. Okay, I'm not sure what I'm punching there. There we go. Okay. Any zeros between two non-significant digits, like here, are always significant. Okay? So these are always non-significant. These are always significant. The problem children, you would say, is these zeros over here. Okay? And the reason they're problem children is because if they're significant or not significant all depends on the presence of that decimal place. So if there's a decimal place there, then they are significant. If there is not a decimal place there, then they are not significant. Okay? So basically, these are really the only ones that you have to worry about. These, always no. These, always yes. These depend on if there's a decimal place or not. Okay? All right, this is going to be the end of this video. There's a part 2 for this section also.